Welcome back. As I already said now, let us try to see the, the fluid that we have taken as water, what is its application region. That means for engineering practices, what is the region of our interest, where do most of the activities in engineering happen as far as water is considered as fluid for our case. So, this is my PT diagram. We got different regions over here and we got solid to liquid and solid to vapor conversion, phase conversion that happens across S to L region or SV region, S to L phase transition and S to V phase transition. Now, there are very few mechanical engineering applications in these regions where we normally come across. In engineering, solid to liquid phase transition and solid to vapor phase transition, we got very few applications. It does not mean that we do not have any applications, but these applications are quite few. We have got ice getting converted to liquid, but we have got very few application from S to V region also. So, application involving solid to liquid condition phase change also are very few as compared to what we have for L to V region. So, we say that this is a region where liquid to vapor transition happen is a very important region for us. So, this region is of very much importance to us. Most of the mechanical engineering applications revolve around liquid to vapor zone. For example, power plant, we got liquid which is in the boiler, which get evaporated to vapor, and we got a turbine, steam, again condensation where vapor to liquid conversion happens. All this revolve around L to V region. So, we got a liquid region, we got a vapor region, and also we deal with this LV line where two phase mixture exists. So, most of the mechanical engineering application which involve water lie around this LV region, and therefore, we say that let us try to study this region in more depth. Because most of the engineering application involving water are in this region, L to V region, we will concentrate more on the studies relating to L, V and L plus V region. Now, here our applications are therefore with respect to power plant, of which I have just talked about, compressors where water cooling is used for compressor, chilled water is used for cooling to take away the heat of compression, very important application for water. Then we have got turbine where water turbine could be used for power production, or steam turbine where again the phase changes are involved from steam to water, the condenser, there are heat exchanger that are involved in these cases. Refrigerant, again we have got a liquid refrigerant, water as refrigerant also, where again liquid is used as refrigerant and again its vaporization also comes into picture, its condensation. So, vapor to liquid condensation also, phase change also has to be considered in most of these applications. And of course, in air conditioning again water plays a very important role, water vapor plays a very important role, conversion of water vapor into water and again vaporization. These phase change processes play a very important role, and these are very important application that normally a mechanical engineering would require to design. Lot of devices have to be designed based on the properties that you come across for water, water vapor and water plus water vapor together. This is our application region, and that is why we say that our concentration will be more on liquid vapor phase transition. So, we will talk more about liquid, water, steam or water vapor and liquid to vapor staying together, liquid to vapor phase transition. Now, in order to understand more about water, water vapor, water plus water vapor, the properties of water for these applications are taken from steam tables. As we have already said, these properties are very difficult to obtain because there is no equation of state available for water. What we refer to is steam table, and this steam table actually this is what we will refer to get these properties of water at different pressures and temperatures. Similarly, the two phase mixture of water and vapor together also can be obtained from steam table. So, here afterwards most of our discussion would go to see the properties of water or to read the properties of water from steam tables, and I will introduce to the steam table that we will refer to during all further lectures. So, what have we learnt till now? We have learnt Gibbs phase rule, where degrees of freedom can be found out for a given mixture of water or phase of water. We have seen that our application region would be more in the liquid and vapor region, and therefore we will study liquid, liquid plus vapor and vapor region. And also I refer to steam tables, from where we will take different properties of water mixture from steam tables. For various applications that I talked about, all these devices will be designed based on the properties that we get from steam tables. Thank you very much.